Good evening, everyone. My name is Ankit Singh, and today I'll be walking you through my machine learning project on the credit score classification for the Paisabazaar.com website using EDA and predictive modeling. The goal of this project was to predict a user's credit score category, whether it's poor, standard, good, or acceptable, using various financial and behavioral features. This kind of classification is extremely useful in the finance sector for loan approvals, credit card offers, and also overall risk management. First, I'll walk you through the dataset we have been provided and the objectives I hope to accomplish using this project. The dataset we have been provided contains a variety of columns like age, monthly in-hand salary, outstanding debt, occupation, number of credit cards, the amount of delayed payments, and so on and so forth. In total, there are more than 25 features present in the dataset, and they provide a well-rounded picture of a person's financial behavior. The objective for us was to clean and analyze this data, extract useful patterns, and then finally build a machine learning model that will classify credit scores accurately. Second step that I performed for the project was the data cleaning and data pre-processing. Start with, I checked for missing values and cleaned them where necessary. I also removed outliers using isolation forest method, especially in critical columns like monthly salary and outstanding debt. Uh, debt. This step helped prevent skewed model training and also helped in reducing the amount of error in the model. Next, converted categorical columns into numerical format using label encoding. For example, occupation and credit mix were changed. I also created a new feature called quarter from the month column, which captures seasonal financial behavior of the user. Now, the third thing I performed was exploratory data analysis or EDA. This part was all about understanding the data visually. Hence, I performed a variety of different plots in order to give an understanding of the dataset we have been provided with. I've used count plots to see how credit scores are distributed in the datasets, box plots to compare income, debt, and age across different credit score categories. I have used histograms with KDEs to study the distribution of numerical variables. And I've also used correlation heat map to check how strongly different numerical columns relate to each other. These visualizations have given me a good idea of which features are more likely to influence credit score in the overall prediction of the credit score. Now, next, I have performed hypothesis testing. To strengthen the analysis, I have also performed a hypothesis testing. For example, I wanted to know if the users who regularly pay only the minimum amount have different average incomes than those who don't. I have a t-test for that. Other tests compared the number of delayed payments between people with poor and good credit scores. Both tests turned out to be statistically significant, supporting some of the insights from the visual analysis. Next, I moved on to model building. After understanding the data with the help of plots, I have built two different models, random forest and XGBoost. Random forest is good at handling a mix of categorical and numeric data and is relatively easy to interpret. XGBoost is a boosting algorithm that generally performs well on structured data. And as we have seen, the data provided is very structured and very detailed. For training, I have scaled the features using standard scaler in the notebook. Then I have split the data into training and test sets and trained both models on the same data in order to provide accurate and similar results. Next, I moved on to model evaluation. To evaluate the models, I have used accuracy, criteria, recall, fun score to provide us with the most accurate and general output possible. Question tells us how many of the predicted positive cases were actually positive from all the provided cases. Recall tells us how many of the actual positives which were there were correctly predicted. While F1 score is used as a balancing act and acts as a bridge between precision and recall. However, accuracy gives us an overall percentage of correct predictions. That is, how many of the predictions made were actually correct from the total number of predictions made. Have used XG Boost before it performs slightly better in performance in terms of accuracy, but both models give fairly good results and perform very well. Next, I would like to talk about feature importance and the correlation between the data. I also visualize feature importance in the random forest model. The top features include credit utilization ratio, number of late payments, outstanding debt, and monthly salary. To wrap up the analysis, I have also used and checked the Pearson correlation between credit utilization and outstanding debt. And surprisingly, they were positively correlated, hence providing a good baseline and a strong detailed data set. In conclusion, I want to say that this project shows how machine learning can be used to classify credit scores accurately, but also highlights the financial behavior that contributes most to a good or poor credit score. Going forward, this model can can be improved by adding more behavioral data, integrating real-time updates, or even deploying it into the financial app that predicts creditworthiness live. I would like to thank everyone for watching this presentation. I hope that I was able to provide you a clear understanding of how the credit score classification can be done using machine learning and data analysis. Thank you, everyone.